There's motion. We're starting with motion. So you have different types of motion, and understanding motion is just the beginning of the whole concept. So kinematics is just a study of motion of objects without considering what causes such motion. Motion is a continuous change in position or direction of an object. Stop. So you have the types of motion. These are all crafts, but let's go through them. You have the random motion, you have the linear motion that you'll be tackling, and also the upward and downward motion that will vary. You consider those. You have the circular motion, rotational motion, auxiliary motion, or vibration motion. You can pause the video and read further about them if you are quite interesting. But distance is a total path length traversed in moving from one position to other. Distance depends on the path taken. Displacement is the distance covered by a body in specific direction. So all what it's trying to say is that you have distance and you have displacement. So let's do a simple sketch here for us to understand it. So point A, this is where it starts from. You move from point A, you move from point A to point B. Now for point B to point C, there is it. So you've moved from point A to point B, or point B to point C. So let's just assume there's a line here. So distance, say distance is the total path covered. So let's give distance of here could be 5 centimeters, 3 centimeters, and 2 centimeters. So distance here our distance is from here, from A to B, from B to C, from C to A. This is our distance. So 5 plus 3 plus 2. That's our distance. Yes. And displacement. Here they are saying displacement is a straight line between 2 points along the direction from the starting point to the final point. So you've gotten the concept from the starting point to the final point. So starting from here and you ended here. So more or less like the distance is from here to here to here. If it's coming back to here. But our displacement is jumping all these steps and directly from the beginning to the end. So this is our displacement. Displacement here is 2 centimeters. I hope it's clear. So speed equal distance over time taken, and there is the unit. velocity equal displacement over time taken. So when define it in the digital form, they have different definition considering the distance and the displacement. But in a work in a work in a workable example, they they um they are worked the same. The distance and the displacement will be given to you as the same. Yeah. You have uniform velocity. No, yes, you have uniform velocity is the constant speed, it doesn't change. And uniform velocity, it changes at a certain point in time. And we have the average velocity, which is the ratio of the total displacement to the time taken. Now, let's do some work example here. You have, before we solve it, so you have 36 kilometers per hour. So we know that the K here stand for 1,000. So it will be 36 times 1,000. That will give us a 36 times 1,000 meters per hour. So you know 1 hour equal 60 minutes and 60 seconds equal 1 minute. So 1 times 60 times 60 should just break it down to seconds, because we said the formula for the SI unit for speed and velocity is meters per second. So you just have to break it down to meters per second. Yeah. So here they've given us an example which says a body covered a distance here could be a displacement of, to be the same. A body covered a distance of 1,200 meters in 40 seconds. What is the speed of the body? You already know the formula for speed or velocity, the same. So just distance over time taken. So make sure you look for the units, not to get it wrong. Very important. The third example says a car took 5 minutes. So 5 minutes here, a minute. So you know that the SI units for the time should be in seconds. So you just have to turn the 5 minutes into seconds, which will give you 300 seconds. Simple. And after doing your conversion, now you can go ahead and solve it. A car took 5 minutes to travel from town A to town B, which are 1.2 kilometers apart. So here too, the K stands for 1,000. So 1.2 times 1,000 meters apart. So that will be for the distance. So calculate the average speed. The average speed is just the ratio of the total distance over the total time taken. And you already know the total distance here. And you've already converted the total time taken here. So you just do the division. A train takes 2 hours to travel along a winding track from Tema to Kano, 108 kilometers apart. You know what you're supposed to do here. Calculate the average speed of the train in kilometers per hour and in meters per second. So they give you 2 hours as the time and the distance 108 kilometers. And the first assignment is A. calculate the average speed or velocity in kilometers per hour. So with the first one, you don't have to convert it because here is kilometers, here is hours. So you just have to do your division, and whatever you get is already in the unit. And for the second one, the B, which is the normal ways you all do, and the standard units for that, you have to convert it. I always say the K here is 1,000, so you just multiply the 1,000 with the numbers just in front of the K. 108 times 1,000 meters. Change the hours into seconds, then just do your division. Simple as that. A train has a velocity. Here they give you the velocity. Previously they used to give you the time. Previously they used to give you the time and the distance, but right now they just want to trick your mind to see how you understand it. So they give you the velocity instead in kilometers per hour. How far? That's the distance. Does it travel in half a minute? So half a minute, you already know what a minute is. A minute is 60 seconds, so half of it 30 seconds, because you are dealing in meters per second. So you just have to convert this as we did previously. 72, as the K is 1,000, 72 times 1,000, or over the conversion for 60, conversion for an hour to seconds, the result will be 20 meters per second. That's for the velocity. Okay, now for the distance, how far? For the distance, you already know the formula, which is velocity equal distance over time taken. So you already know the velocity, which is 20 meters per second. The distance you don't know, but you know the time. The time is half a minute, so 30 seconds here. So you just have to do your cross multiplication. So the distance equal 20 times 30 here. So the distance will be 600 meters, as they've done it here. So I hope we are not moving too fast. Try and catch up. It's a very interesting topic, and very simple too. An ambulance underwent a displacement or distance. In the context of example, they are all the same. So an ambulance underwent a displacement of 100 kilometers in 2 hours. Determine the velocity of the ambulance in meters per second. So you know what you're supposed to do here. You know what you're supposed to do here. You are not going to waste time on this, because you can pause the video and do it by yourself. You have a lot of trial questions that you can try it. Let's just go through to the question for you, so that when trying it, you might get a further understanding of it. So a boy cycles 7.5 kilometers to school in 2.7 minutes. Find the average speed in meters per second. That is a unit for velocity. And you know what you're supposed to do here. A car traveling at uniform speed of, they give you the speed, they give you the velocity, cover the distance between two stations in 2 minutes. You know what you're supposed to do here. Calculate the distance in the station. So we know the formula, V equal distance over time, making distance a subject. Find your result.